Welcome to EDU World Space.
Let's take a look at several functions and see which ones might be state functions and which ones might be path functions for thermodynamics. And so let's say we take a look at temperature, we take a look at energy, heat, work, and entropy. And in science, if something's given a capital letter, it is a state function, and it does not matter what path you take, but if it is a lowercase letter, it is generally a path function, so it does matter the path you take to get from one state to another. So in this particular case, we have capital T, capital E, and capital S, which means that T, E, and S are state functions. And Q and W are path functions. Now let's say we're dealing with a reversible process. We're going from state 1 to state 2 and back to state 1. How many paths can we take from 1 to 2 and back to 1 that are reversible between those two states? Well, there's only one path. Oops. Sorry about that. There's only one path when we're dealing with a reversible process. All right, so we've only got one path. And what are some ways that we can express the change in energy or the change in entropy in a system if we're doing a process isothermally? Isothermal means same temperature. So we're going to keep the process at the same temperature throughout. Now, if we're doing this and we're doing this for a reversible process, that gives us some information. It tells us that the heat that the system is going to use is reversible. And it also tells us, if it's a reversible process, that the work that we're going to be able to do is at its maximum. So if we want to be able to describe the change in energy in terms of work and heat, what we can do when it's isothermal and reversible is say that the heat is equal to that reversible heat. And we can say that that work is the maximum work that we can accomplish. Well, we know that delta E is equal to Q plus W. Well, now we have Q reversible and we have max work when it's isothermal and reversible. So we can say that the delta E is equal to Q reversible plus the maximum work. And if we're going to look at entropy, well, we know that delta S is normally heat over absolute temperature. Well, now we know when we have a reversible process that that's going to be the reversible heat over the temperature.